Well, happy E-Day to everybody. We're kind of in a situation that is not really good for E-Days. We're right before a test. We want to review. I'd like to have the chance to go over your questions, but we're going to have to do that through email throughout the day today, which is Friday, January 30th, because the next time we come to class, we are going to take our test on radicals and radical functions. And so what I want to do with you here in this video is go over what I was planning on doing the next time we came to class. I have 14 questions here, which are like a review of what you'll see on your test, very similar to your PowerPoint that you guys did as a review. But I'm going to go over these questions with you. What I would do if I were you is I would take a look at like number 1 and pause the video, see if you can do it on your own, and then start the video to make sure that you were able to get the correct answer. I'm going to go through this kind of quick, knowing that you guys can pause it if you want to have more time to think about what it is that we're going over. So the first one is simplifying a radical. We have a cubic, and so we're going to simplify the cube root of 54. Now 54 is 9 times 6, and 9 is 3 times 3, and 6 is 3 times 2. So I have a group of 3 threes, so I'm going to pull that out, and then eventually I'll have a cube root, and I'll need this leftover 2 to be inside that cube root. I also have 6 x's, and if I pull those 6 x's out in groups of 3, I'll have 2 groups. So I have 2 groups of x's on the outside. I'll also have 3 groups of the y's with 1 y left over. And so our answer to number 1 is 3x squared y to the third times the cube root of 2y. Let's move on and take a look at number 2. Number 2, we're going to simplify the square root of 18 times the square root of 50x to the fifth. So this is a little bit more complicated, supposedly, because we're multiplying radicals together. So when we multiply radicals together, we can just multiply 50 times 18. Let's see, 50 times 2 is 100. That would be 9 2's, so that would be 900. And then x to the first times x to the fifth would be x to the sixth. And I'm taking the square root of that. Well, 900 is 9 times 100. We know that the square root of 9 is 3, so I can pull the 3 out. We also know the square root of 100 is 10, so I can pull both the 3 and the 10 out. 3 times 10 is going to be 30. And then I have x to the sixth, and if I take those out in pairs, that would be x to the third. Now, because the original question had an odd exponent here and an odd exponent here, I would not need absolute values around the 30x to the third. So our final answer is 30x to the third. Number 3, we're going to simplify number 3, but number 3 is a little bit more complicated, supposedly, because we are dividing. But the same rules go when we multiply. We can divide stuff inside the radical together. We can also we can simplify the radicals first, or we can just divide what's in the radicals first. For example, if we take 32 over 4, that's 8. And also, x to the fifth divided by x to the second is x to the third. So if we simplify the fractions, what we get is the cube root of 8x to the third. And the cube root of 8, we know, is 2. And the cube root of x to the third is just x. And so our final answer for number 3 is 2x. All right? You guys are all going to be doing these in stations, but we're doing them at home instead. So let's take a look at number 4. We're going to simplify another square root. We could simplify what's in the radicals together first. Like, for example, we can make this 6 over 3 is the square root of 2. But now we have a little bit of a different situation, because x squared over x to the fifth is x to the negative third, which means we have the cube root, or the square root, of x to the third in the denominator. Now, we could simplify x to the third a little bit right away, because we can pull out a group of 2 x's, and we can write this as the square root of 2 over x times the square root of x. But what we'd really like to do is get rid of the radical that's in the denominator. So what we're going to do is multiply the top and the bottom by radical x, which means in the numerator we're going to have the square root of 2x, and in the denominator we're going to have x times another x, which is x squared. So we have 2x over the square root, or x squared, which looks like this. Moving on, number 5. And again, as you do these, try these on your own before you watch the video. Try to rationalize this denominator on your own. Check it to make sure that you got it right, and then move on to number 6. But what I'd like to do is I'm going to multiply both the top and the bottom by the conjugate of the denominator. In other words, I'm going to multiply by radical 3 minus radical 8. And I'm going to multiply the top here by the same thing, radical 3 minus radical 8. Because this really is just multiplying by 1. It won't change the value, but it will rationalize the denominator. So let's do the numerators first. We're going to take radical 3 times radical 3 is simply 3. I'm going to write small here so we can get it all in the video. Radical 3 times radical 8, negative radical 8 is negative radical 24. Negative radical 8 times positive radical 3 is another negative radical 24. And then if I multiply negative radical 8 times negative radical 8, I get positive 8. So simplifying what I have here, 3 plus 8 is 11 minus 2 radical 24. But radical 24 can be simplified. That's the same thing as the square root of 4 times the square root of 6. And the square root of 4 we know is 2. So this is 11 minus 4 radical 6 on top. But then I want to multiply the denominators together. I'll have radical 3 times radical 3 is 3. Then I'll have a negative radical 24 and a positive radical 24, which will cancel each other out. And then a negative radical 8 times a positive radical 8 is a negative 8. So 3 minus 8 is negative 5. And our final answer is 11 minus 4 radical 6 over negative 5. Which looks like that. That was a tough one. Take a look at number 6. We're going to evaluate this expression, which means I could multiply these two numbers together because they are the same exponent. It's just like the cube root of 2 times the cube root of 32. That would be the same thing as the cube root of 64. And we know that the cube root of 64 is just 4. So I probably could have made another step here. I could have written this as the cube root of 2 times the cube root of 3 because I could have changed them into radical form. So the final answer here for number 6 is simply just 4. Let's take a look at number 7. Number 7, we're going to evaluate this expression. Whenever we take a power to a power, that means we're going to take the whole thing, 125 to the negative 2/3 power, and then we're going to take x to the negative 15th to the negative 2/3 power. And when we take a power to a power, we should know that we multiply those things together. So 2/3 of 15 is 10, and it's a positive 10 because those are both negative. So if I rewrite what I have here, x to the 10th is going to stay on the top, but then 125 to the negative 2/3, well, it would be 125 to the positive 2/3 if I put it on the bottom, and that's the same thing as the cube root of 125 to the 3rd power. The cube root of 125 is 5. The square root. The cube root of 125 to the 2nd power. So the cube root of 125 is 5, and 5 squared is 25. So I'm going to have x to the 10th over 25. All right? And that is number 7. Okay? Moving on, let's take here a look at number 8. Now we're solving equations. And when we solve this equation, we want to start by getting the radical exponent, that whole thing that we're taking to the exponent by itself, which means we're going to start by adding 3 to both sides. So I'll have 2, and then x minus 4 to the 3/2 power is going to equal 16. But then I want to get rid of the 2, so I'll divide both sides by 2, and then that'll just leave me x minus 4 to the 3/2 power is equal to 8. But then I want to get rid of the 3/2 power, so I'm going to take this entire side to the 2/3 power, because when I multiply 3 halves times 2/3, I just get 1, and x to the fourth to the first, or x minus 4 to the first power is just x minus 4. But if I take this side to the 2/3 power, I want to take this side to the 2/3 power as well. That means I'm going to take the cube root of 2, or of 8, and then square it. The cube root of 8 is just 2. It's a cube root. If it was a square root or a fourth root, then it'd have to be 2 answers. But if it's the cube root, it's just 1 answer, that's 2, and 2 squared is 4. So then I'll just add 4 to both sides, and x is 8. Okay? And so number 8 is our answer. Let's move on to the next question, still solving equations. This is actually just a radical. So we have this radical is already by itself, so I'm going to square both sides. If I square 3x, I'll have 9x squared. And if I square this entire side, I'll just have 3 plus 6x. So what I'm going to do is get everything on one side. So we'll have 9x squared minus 6x, and then minus 3 equals 0. And be nice if we can factor this. Let me try that here real quick. Let's try, oh boy, let's try 3x times 3x, and then we might try 3 and 1, except one of them is going to have to be negative and one's going to have to be positive. I know that 3x times 3x is 9x squared. I know that negative 3 times 1 gives me negative 3, but my middle terms, this is negative 9x, and this is positive 3x. And negative 9x plus 3x does indeed give me negative 6x. So it does factor. I probably could have been smart and factored a 3 out first. Didn't do that, but we can go on and we can solve it from here. That means that 3x minus 3 equals 0, or 3x plus 1 is equal to 0. And here, if I add 3 to both sides, 3x will equal 3. And then if I divide by 3, x is 1. Now, I think that is one answer. The other one, if I subtract 1 from both sides here, then I'll get 3x is equal to negative 1. And if I divide by 3, x is negative 1/3. I think that is the other answer. But what we should probably do is just check these, because one of them might be extraneous. If I start with 1, and I plug 1 in here, on this side I'll have 3. And if I plug in 1 here, I'll have 3 plus 6, which is 9, and the square root of 9 is 3. So 1 is a good answer. Okay? However, negative 1/3, I can tell, is not going to work, because if I plug a negative 1/3 in here, 3 times negative 1/3 is negative 1. And I can't take the square root of this and get a negative number, because I want the principal root, which means this is not a real solution. It's extraneous, and so it's really not a solution at all. All right? So that's number 9, and the correct answer, as we said, is 1. Let's take a look at number 10. Still solving, or we're graphing radicals this time. So when we graph this one, we are going to start with our idea that we have y equals the square root of x. We know that's half of a sideways parabola. The only thing is, this one starts at 0, 0, and what we have here is not going to start at 0, 0. It's going to be shifted 2 units to the right and 3 units up. So it's going to start at the point 2, 3. That's a 2, 2, 3. And it's also not going to start in the regular fashion. Normally, we start at 0, 0, we go over 1 and up 1, and we go over 4 and up 2, and we have half of a parabola that looks like that. But these vertical distances of 1 and 2, we're going to multiply by the a value, which in this case is negative 2. So from our vertex, normally we go over 1 and up 1, but now we're going to go over 1 and down 2. So we're going to be at the point 3, 1. We also normally go over 1, 2, 3, 4, and up 2, but now we're going to go down 1, 2, 3, 4. So this is the point 1, 2, 3, 4, 5, 6, negative 1. And the parabola, or the half of parabola, or the curve, is going to look something like that. All right. Let's move on from here. Here's our answers. Let's move on from here, and we're going to graph. This time it's a cubic function. And so now we're going with the general idea of y equals the cube root of x, which is what we call the Egyptians graphs in class, where we started at 0, 0, and we went over 1 and up 1, and over 8 and up 2, and then left 1 and down 1, and left 8 and down 2, and it kind of looked like that. But we're going to shift it. We're not going to start at the point 0, 0 as we did here. We're going to start at 1, 2. So when I graph this one, I'm going to start at positive 1, positive 2, which is here. Probably should have made more room because I'm going to run out, I think. But normally we go over 1 and up 1. Now I'm going to go over 1 and up 3. And normally we went over 8 and up 1, but now I'm going to go over 8 and up 6. Same thing, I'll go left 1 and down 3, and left 8 and down 6, because I'm multiplying these vertical distances here by the a value, which is 3. And so it's going to be a curve that looks something like this. And for a better idea of where those points are at, we're going to go here, and you can see that those points are all labeled. Okay? So when you graph this on your test, you're going to want to label 5 points as well. 3 points on the square root graphs, 5 points on the cubic graphs. All right. Number 12. Now we're getting into some things that, this was actually from our first lesson on this unit, which was all the rules of exponents. And so this is a review of some of those. I'm going to take everything here in this set of parentheses and square it. Like 3 squared is 9. X squared, when I take a power to a power, I multiply. That's x to the 4th. And then it's going to be y to the negative 8th. 3 to the 3rd, however, in this set of parentheses, 3 to the 3rd is 27. X to the negative 5th to the 3rd, well, that's x to the negative 15th. And then y to the 3rd, y to the 1st to the 3rd is just y to the 3rd. So now I have things outside of the parentheses, and now I can multiply those things together. Well, hopefully I can. 9 times 27, I don't know that one off the top of my head. So 27 times 9 is 63. 18, so 243. So 243. But then when I have x to the 4th times x to the 15th, I'm going to add those exponents. That's x to the negative 11th. Same thing with the y's, y to the negative 5th. But then I want any negative exponents to be positive, and in order to make those negative exponents positive, I'm going to put them on the bottom. 243 will still stay on the top, but then I'll have x to the 11th and y to the 5th in the denominator. So our final answer for this one looks like that. Moving on, hang in there. Number 13, change to exponential form. And so we haven't really done a whole lot of these in class, but I don't know if they're that difficult either. This one is simply going to be x to the 9 over 3. X to the 9 over 3, which is x to the 3rd. Times, this one is x to the 4 over 2, because that's an understood square root there. X to the 4 over 2 simplifies to x squared. And when I have x to the 3rd times x squared, I add the exponents. That's x to the 5th power. Okay, so that is number 13, and it's x to the 5th power. And then our last one here, number 14. Looks kind of like a simple question. We're going to change this to exponential form. We have the square root of x times the cube root of x. Well, this is x to the 1/2, x to the 1/2, and this is x to the 1/3, and I'm multiplying. So just as in the last question, I'm going to add the exponents together. So I'm going to take 1/2 plus 1/3, which means we need a common denominator, which is going to be 6. 1/2 is 3/6. 1/3 is 2/6. When I add them together, I get 5/6. So this is x to the 5/6 power. There you have it. You can go back over those, and I think I've explained them pretty well. But if you have questions, please contact me through email. Also, if you have questions on our PowerPoint, contact me through email as far as that goes as well. Be sure that the next time we come to class that you are ready to take our test on this unit. Our test will be the very next time we come we come to school. So make sure you're ready for that. Have your homework packet ready to go as well.